So our next presentation, which we will finish, is which we will continue actually because we already started it, is the relational operators and flow control. So we went to introducing while statements, and while statements were used to create loops. As you can see in this particular homework assignment, you will have to create a loop, or perhaps even more than one loop, maybe a nested loop, where you can test conditions to determine where this particular prime number is a candidate, a real candidate to become prime number, and then the next one, and the next one, and the next one, until you hit that limit which the user has specified at the beginning. So examples of loops which will be directly useful in this particular homework. And I think perhaps let me start another project. I will just say File, New Project, and create a new project, and name that project Homework 4 Demo, I guess. Again, the same location, and simply change it to main app. All right, so I've just created Homework 4 Demo, which I'm looking at. Let me keep it brief as much as possible, and we'll try using this blank program right here. So it says basically this is a very typical example of a loop, is when you have again, when copy and paste doesn't work very well, then you say source format, right? So which kind of makes it look very, very neat. And I think I have some messed up, I don't know what I have messed up, but I will try my best to, oh, there's a missing semicolon, that's why. You also, if you keep the shift key down and use your arrow keys to make a selection, you can use the tab key to actually shift your code up and down. Shift tab brings it back. Also useful. All right, so let's see what this code does and what the so basically we have a purposeless integer x. I will actually change its name to xx because I don't like single character variable names. So 2 x's are better than 1.
Sorry.
That
3 was what you mean.
What's that?
I thought you defined 3 letters as being your standard.
No, not necessarily. Sometimes you do use 2 characters. Yeah. In most cases, it's probably 3 and more. Yeah. But 2 characters is okay. Much better than 1 character. All right. So let me actually try to compile this and see if everything works properly as expected. Since I just copied and pasted, something makes it unhappy. Let me build and see what's going on. Illegal character. So as I was pasting it, something here, perhaps this is an illegal character? Yes. It was another version of dash, which fancy word processors create. So it was not a real minus. It was something else. So that's a good way to combat people from copying and pasting, I guess. So let me save that. So I replaced it with a real minus because I thought, what can possibly be illegal in this? It looked good, but it was just this dash symbol, which was not a real minus, that made it hard. So now, of course, it's the build is successful. Let's see what's going on in this code. So a couple of integer variables, x is initialized to 10, total is initialized to 0, and apparently there is an attempt to accumulate values from 10 to 1 or from 1 to 10 in this particular loop. And we're saying as long as x is greater than 0, make x, decremented by 1 each time we're trying to accumulate. And essentially say, and then each time we're trying to accumulate number between 1 and 10, then simply add that number to the total. So the outcome of this is, of course, the number which should be like 1 plus, 10, 10 plus 9 plus 8 plus so forth plus 1. That kind of sum we're trying to accumulate. So let's print what this number is. Print line, I will simply print the number total. Yes, of course, thank you. Okay, so let's see what the number is. 55. Okay. So what happens is this. We have a loop that does this individual. So essentially, we start with 0, right? And then we kind of grow that 0 to become 10, then 19, then 19 plus 8 plus 7, and so forth. And it happens because we have a loop. And the loop says, okay, let me take a look at your condition. There is a greater than operator, compares x with 0, right? So as long as x is greater than 0, let's do this and let's do this. And as soon as we hit this closing brace, sometimes when there is a lot of code like this in a loop, the loop really kind of long, sometimes it may be useful to actually mark it like this, just to remind yourself that this is a closing brace that closes the loop. So let's go back to the original version, right? So if you found a way to hit this closing brace, your thread of execution is transferred back to this line, and the condition is tested again. If it's true, you begin to execute this and everything that follows. If this condition here is not true, then you simply jump out of the loop, as we say. And your next statement after the closing brace of the loop executes. And in it, we print the total. By observing what's going on right here and what's going on right here on this line, I may actually state, kind of safely say it, is that xx is the loop controlling variable, because the condition of this loop heavily relies on the value in this variable. If I by mistake forgot to modify it, and so xx never is changed, in my case it was decremented by 1, then I'm in trouble, because this is truly an endless loop. It's a runaway train, and the program really isn't going to do well. I guess we can kind of test this out and see what happens. So the program starts, and it continuously adds xx, which is 10 to begin with. It continuously adds it to total. So the total apparently reaches its maximum value allowable for an integer and just wraps around and just keeps, it's truly, it's not very logical, it's not well controlled, it's not good. It's the conditions aren't good. However, the Java runtime environment doesn't see anything wrong with adding numbers, checking a condition, and in general having a loop. So the Java runtime environment thinks that this is exactly what we want our program to do, which is obviously perhaps not the good thing, but that's the situation. In this case, you can check the status of NetBeans telling us that the task is running, and there's this little button here to cancel process. And perhaps that's the only way for us to deal with this, just to cancel this process and say, yeah, you want to cancel this, and there is a way for this environment to tell Java Virtual Machine to stop running this program. And so it stopped, and we come back. I would suggest if you have situations with endless loop and similar situations where the program is taking longer than usual to execute or something, and you really don't want to wait, you instead of letting it hang in there somewhere in the background, which is possible, like for instance, if I start it again, it's possible for me to go right back here, and while I know it's running endlessly, right, it continues to run, executes this really silly loop forever, I can go back and already start editing my code and maybe even try to start it again or whatever. So, but I would advise if you have a program that really doesn't behave well and it doesn't end properly, then you hit this button and say, yes, cancel that program execution. Makes sense, right? Okay, any questions about this particular code? So then let's save it.